Hi, my name is Tandoh. I'm a senior student at WVAS College, and I'm presenting on comparing the body mass index of zebrafish fed on a normal diet versus a half-fat diet. Moving forward, I will start with scientific background on the obesity. And on the background, I have a few points to talk about it. One, the effective use of animal to understand illness. Animal models are for us to better understand illness, to recognize and develop successful treatment. Two, zebrafish are framework for examining metabolic disease. Zebrafish are a highly conserved digestive system, including organs such as intestines and liver. They are used as model of obesity. We have the predominance of overweight, and weight has consistently expanded. According to WHO 2007, more than 1.9 billion were overweight, and of these, over 650 million were obese. Mine's model for examining the impact of diet. The drug we are investigating was first tested in the rat model. Then reason or importance of studying. The United States is facing different kinds of disease. This is because the food we eat contains high cholesterol. These high cholesterols have led to many diseases such as heart attack, atherosclerosis, and diabetes. The Western diet may predispose to chronic disease. The Western diet contains excessive saturated and trans fat acid. The Western diet is primary cause of obesity and includes high intake of carbohydrate and the saturated fat. The use of zebrafish in studying the effect of dietary acid. This is because fish has 75 homologous to human genotype. My objective, comparing the male and the female zebrafish based on dietary groups. The normal fed diet to be given 5 mg of pure antimia saline cyst. The half-fat diet will be given 5 mg of antimia plus the 30 mg egg yolk powder. Then using computer tomography scan the body mass index. Then this is my flow chart of the testing the hypothesis. First of all, the food is going to be measured, given to the male and female zebrafish for 1 day, for a day, for 8 weeks. That's normal fed diet, the half-fed diet, and the half-fed diet plus the drug, that's anathiotretone. For every week, the zebrafish are weighed and measured for the length in order to calculate the body mass index. Then at the end, total of the food and the calories will be going to be calculated. That the left food particle is going to be detached from the food measured. Then after 8 weeks, zebrafish fasted overnight and sacrificed. Body fat volume measured, viewing the viscera and subcutaneous by the computer tomography. Graph of body mass index is going to be plotted. Then what is body mass index? It's the measure of the body fat based on height and the weight. The body weight and the length of the zebrafish is going to be measured weekly. The length of the zebrafish is going to be measured from the head to the end of the body. Calculation of the body mass index for the zebrafish is dividing the body weight in gram by the square of the body length in centimeters. My research hypothesis is if zebrafish are fed as a half-fat diet, then they will become overweight when compared to zebrafish fed on a normal fat diet. Overweight zebrafish will have more visceral and more subcutaneous adipose tissue than the normal fed zebrafish when measured with computer tomography. Now this is my setup experiment. So we have the female zebrafish, both male and female zebrafish on normal fed diet, and then we have the female and male zebrafish on a half-fat diet on one system containing regular water. And we have the isolated fish because we don't want to mix the drug with the normal water. So we have the female zebrafish and the male zebrafish. We will get the half-fat diet plus the drug, that the 80 anathiotretone. So each week, measurement plan for experiment. Each week, adult zebrafish for male and female normal fed diet will be going to be giving 5 mg antimia. Normal male for female, male and female half-fat diet is going to be giving 35 mg antimia plus egg yolk powder. Then the drug for male and female with the high-fat diet is going to be 35 mg antimia plus the egg yolk powder. You're going to weight all the fish, measure the length of each fish, take the average measurement per tank, then we calculate the body mass per fish. At the end of each 8 weeks, weight all the fish, measure the length of each fish, then take the average measurement per the tank. Then we are going to sacrifice the fish, perform tomography on 10 fish, dissect intestine on 10 fish, and process for RNA-seq, and processed fish intestines for transmission electron microscope. Mine is on tomography. So what type of fat deposit? Tomography. Visceral fat deposits are associated with cardiovascular disease. Computer tomography detects subcutaneous and visceral fat deposit. The zebrafish placed under computer tomography expect that fish fed the high fat diet will have more visceral body fat as compared to the normal fat diet. When you compare here, we have the normal fat diet and the high fat diet. So we can see that the high fat diet has more visceral and subcutaneous fat deposit than the normal fat diet. Now, determine the concentration of the drug in the high fat diet. It is known that zebrafish do not eat 100% of the diet fed to them. We wanted to ensure that each fish gets at least 10 macromole of AT per day. We feed 0.7 gram of high fat diet to 6 tanks of fish for 20 minutes and measure the percent of high fat diet consumed. That is 35 milligram per fish times 20 in each is 700 milligram. So we then calculate the concentration of the drug needed. So I'm going to base on this graph to find out how much high fat diet will the zebrafish will consume per day. So this is the first day on 23rd February. This is the amount of food consumed for both male and female zebrafish. And after 20 minutes, the food is being calculated, the food is being measured. And then on 24th, we did the same thing. So this is the graph for the 23rd of food consumed. So after the 20 minutes, the food is going to be removed and is measured. And this is the graph being plotted. And then on the 24th, we did the same thing. So at the end, we combine both the data. The other 23rd and the 24th, to get how much high food will the zebrafish consume per each day. And at the end, we conclude that zebrafish consume 57% of the high fat diet, so that we can use to formulate our diet, our drug, that's annatto triton. We found out how much annatto triton was needed for the weight of 0.3 gram fish. The effective concentration used was from 1.5 rats heart per fusion at 10 macromole. An equation was formed to know how much the drug is needed for 1.5 gram rat heart to make the 10 macromole of annatto triton. The equation X is, which is the amount of unknown drug. So 1.5 times 10 to the power of 5 gram of annatto triton over 1.5 gram rat heart is equal to gram of annatto triton divided by 0.3 gram fish. And then our final answer was 3.10 raised to the power negative 6 gram of annatto triton per each fish. So calculated those based on 0.5 grams into about 57% diet consumed to ensure that all fish get at least 10 macromole 80. That's annatto triton. That's the drug name. So what has been done so far? Each condition has a total of 40 zebrafish, 20 male zebrafish, and 20 female zebrafish. The fish have been put into the system. Diets have been made based on their condition for each week. First week measurements have been recorded. Now, anticipated results. The anticipated results of this research included comparison of the visceral and subcutaneous adipose tissue of zebrafish to 3 dietary groups: the normal fat diet, the high fat diet, and the high fat diet with the drug, that's 80. It will be expected that the increased weight and the fat body fat volume in the high fat diet compared to the normal fat diet or the high fat diet plus the 80 group, as measured by the body mass unit of the fat tissue using the computer tomography. Then expected results based on our anticipated. So we have normal fat diet projected weight gain at 1% per week for normal fat diet, and then we projected weight gain 5% per week for high fat diet. Then we combine and then we compare. So at the end, this is our data graph showing the anticipated weight gain. We had the normal fed diet projected weight gain at 1% week, and the normal fed high fed diet projected weight gain at 5% week. So when you look here, we have the normal fed male. The light blue is normal fed male, and then the brown is the normal fed female. So when you compare, we get to know that the female has increased in weight than the normal fed diet in male. And when you come to the high fed diet, we can see that the deep blue serve the high fed diet for female, sorry, and then the high fed diet for the male represents the yellow. So when you look at it, we conclude that the female has increased in weight more than the female, more than the male in the when we are using the high fed diet. So future direction, zebrafish must be measured for weight and the length each week. At the end of the 8 weeks, the zebrafish must be fasted and sacrificed. The sacrificed zebrafish must be imaged and by computer tomography. Graph of the body mass must be plotted. My acknowledgement. Any question?